In this video, we're going to look at how you can build a digital scale with VEX. You've just learned about deflections of beams, and basically as you add weight, you can go and basically measure the deflection. You can calculate the load once you know the modulus of elasticity for the material and the geometry. You can basically now take measurements, rewrite the deflection equation to be able to determine the weight. If you look at how you rewrite that equation, basically it's just a constant. The deflection times some constant equals the weight. And that's something we can very easily implement in a VEX program. Fortunately, we just received 6 digital displays that we can hook into our VEX Cortex. So in this activity, you're going to basically go and add a digital display to a Cortex, and you will read an ultrasonic sensor that will measure the beam deflection as somebody stands on the 2x4. And after putting in appropriate numbers, basically known weights and known distances, you will be able to make a digital scale. To get this going, what I wanted to do is to kind of show you the program. It's a very simple program, but let me go through and show you the setup that's going to be needed in this. Under motor setup, if you go to the digital tab, on digital port 1, add a tare switch. Tare is just zeroing the scale, and when you start it off, you're going to see a negative number. You want to be able to record the current deflection so that as the beam bends, basically the undeflected value off the sensor, okay, you want to record that. So that's how you're going to know what 0 is. So set it up as a touch sensor. On digital port 2, and it turns out it'll be ports 2 and 3, I want you to define that as deflection and use sonar raw. Basically, if you drop down, go down to sonar, use raw, that will give you the greatest range of numbers. Centimeters, millimeters, inches just do scaling. Raw is basically about as high resolution as you get. So do that, and it will automatically map the second port digital 3 because this device requires 2 ports. Okay, once you've got that, okay, you're all set up in here. Your program is going to be real simple. We're going to use 3 variables. First is integer tar distance. This is basically the value off the sensor. The sensor provides whole numbers, so we don't need a floating point calculation in here. So make it integer. You can initialize it to 0. And then float, which is a decimal number. Weight, that's what we're going to calculate. Known weight and known distance. Okay, these values, you're going to weigh somebody who is going to be on the beam, so you'll know what their weight is, and using the sensor, you'll know the known distance. What you're going to do initially is, I have these 187s in there, set them to 1. Okay, so basically, setting them to 1 means there's no scaling. When you look at the reading, you will know exactly what the deflection is. So set this program up with known distance and known weight equal to 1, and that's going to be your first part. Your program under task main is you're going to do a while loop that runs forever. It's a typical control loop. And put in an if statement. If sensor value tar switch, that basically means it's pressed. We could put an equals 1 in here, but it turns out the sensor value returns 0 or 1, 1 if it's pressed, 0 if it's not. So we can just put the sensor value of the switch right in there. If it's pressed, set tar distance equal to sensor value deflection. Okay, so basically read the sensor. Now here is the equation we're going to use to calculate the weight. Weight is going to be the tare distance, basically the undeflected beam, minus the sensor value of the deflection. This number is smaller, so tar distance minus sensor value deflection gives us a positive number in here, times known weight divided by known distance. This distance is in the same units as this distance, so this is the proportion, known weight over known distance. Don't forget to put semicolons here and here. To display it on the digital display, use the display LCD number command, and incidentally, if you come over, it will be, where do we have it under? Natural languages, sensors, sound timing. Oh, here it is, under display, here's your commands over here. The one you want is right here for number. It has a couple of variables. N line, the first one is which line number do you want. The top line is 0, the bottom line is 1, so we have that. The next variable is the position. We're going to start in position 1. This is the value we want, what we just calculated as weight. Now, this command only displays the whole number portion, so the decimal part will be lost on this, but don't worry about that. And 6, how many digits could it possibly display in its maximum value? So we're just putting 6 in here to be able to do that. So this will display the number on the second line. Incidentally, the top line will be the program name. If you haven't cleared it, that's what it turns out to be. And if you did not put a weight statement in, these numbers would be changing so fast that you would not be able to read them. So put a weight statement in. I put weight 0.1. You know, whatever feels comfortable to you, put a weight in here, but do at least 1. Okay, what I'm going to do now is show you the setup. Yours, I've got a little setup made out of a foam beam, and basically we're going to look at, see how this works. You, of course, are going to have 2x4s with people standing on them. So let's take a look. Okay, and go to a bigger screen. Okay, here's your cortex. Okay, that we have here set up, and you'll notice that we have basically, here's our switch. Okay, we have our switch. This is going to be the switch you're going to use to tear. And then after that, you have 2 leads that come off of the ultrasonic sensor. Okay, there's the beam with the sensor underneath. So basically, as the beam deflects, the distance is going to change. Okay, when you hook up your ultrasonic sensor, it has 2 cables. One says input, the other says output. The input, which has the yellow wire, goes in the first digital port that you assigned. Okay, we had used digital 2. So the yellow line is on the digital 2. The orange, which is the output, is on digital port 3. So that's how you connect that up there. The other thing that you're going to notice is here is our digital display. Okay, and hopefully you can see it is reading values. Negative 137 there, 139 is floating around. It has a Y cable, a special serial Y cable, and the Y cable has 2 wires on it. One plugs into TX, the other plugs into RX. The one with the white wire plugs into the TX. Okay. Now, the other end of this connects to a port that we've never used before. Okay, if you look over here, there's some sideways ports, and one of the port is labeled UART2. UART stands for Universal Asynchronous Receiver Transmitter. It's basically a serial communication port. You're going to put that cable into that UART2 port. Notice the blade is on this side over here. Okay, so when you do this, the blade is going to be over onto the side. You snap that in to be able to do that. And that will set everything up. Right now, if you take a look, as I said, we're displaying a negative 436. Okay, what we do is press the tar button. Okay, so I press that. And now if you look, you're going to see we have values that are floating around 0. There might be some negative values, 1, negative 1, or whatnot, but this has been done. After you've set it like this, with your scales, your distances, and your known weight set to 1, you're going to put your known weight on. Okay, so let me go put the weight on here. It deflected the beam. Now that the beam is deflected, okay, you can take a look over here and you can see we have a reading. For example, in this case, we've got like negative 24, 25. We can weigh this device, put in our known deflection as 25, put in whatever weight this is. Yours, it's going to be a person in pounds, so you'll put that in there, and those are going to go in the known weight and known distance. Update your program, resubmit it to the VEX, and you will now be seeing actual weights. So let me go ahead and do that. Okay, let me pop out of here. I'm going to switch this back. Okay, and I've actually got this plugged into my laptop. So let me go just update the weights here. Okay, we had a 187 grams for the weight, and 20 for that large one. It was 29. Let me compile. Okay, download it, and start the program out. Okay, so let's take a look again. Okay, if you take a look, we're getting this really big number here, negative 2,000, 669. Press the tar switch. Okay, and hold it for a while so it gets a good reading. Okay, now we're floating around 0. Oops, I actually had my weight in there, so I'm going to take the weight off and press the tar switch. Okay, there we go. Okay, so there we are. Now I put my component on there, and I'm coming up with around 150, 140. So 149, when I weighed this, it was something like around 150 grams. So you can see I'm kind of floating around the value. Okay, there's a little bit of vibration going on here as I'm talking, so it's affecting the readings, but you can see we now have something that sort of represents the value that we're working with. Okay, that concludes this video on creating a digital scale.